Special missions. So special missions, in this topic we are going to see stepper motor, servo motor, AC
Stepper
and
motor
both DC
It
servo
basically
motors,
converts an
AC.
electrical pulse in the form of mechanical movement. So whenever you give a pulse here, that will be converted in the form of a shaft movement here. So if a shaft will be connected to any part of the load here, so whichever load you like to rotate with a particular angle, in such case your stepper motor can be used here. So normally, for example, if you take a CPU, when you're pressing for CD drive, when you press, the CD drives comes out. After placing the CD here, once again when you press it, the CD drives goes inside. So this action, so whenever you give a pulse here, the drive is either open or it is sent out, open or closed here. So the operation here is done with the help of a stepper motor here. So stepper motor, as I said earlier, so each input pulse is converted in the form of a incremental shaft position here. So for rotating the shaft with a particular angle here, we have a formula 360 degree divided by m into nr. So where m is the number of stator phases, nr is the number of rotor phases. For example, if it is your stator is a 3-phase and rotor if you have 4-phase, when you multiply you get 30 degree, which means that for each pulse the shaft position is rotated at an angle of 30 degree. So we have one more formula for step angle here based on rotor teeth and stator teeth. So in the earlier formula we have considered rotor and stator phases here, but here rotor teeth and stator teeth. The formula is nr minus ns into 360 divided by nr into ns. So types of stepper motor: variable reluctance motor, permanent magnet motor, and a hybrid motor. So variable reluctance stepper motor, it's nothing but your rotor position is aligned in such a way that it is at a minimum reluctance position. Minimum reluctance position, the distance between these two is going to be very less, which means that the air gap is less here, so that more flux can be interacted here. So the construction view of it, we have 3 windings here, stator winding. One is A dash, B dash, C and C dash here. The position of it is represented as 1, 2, 3, 4, 5 and 6. And this is the rotor which has a position 1, 2, 3 and 4 rotor teeth. So when the coil, that is your stator coil A dash is energized here, which means that the rotor 1, 3 position will be aligned in such a way that it will interact with the stator 1 and 4 position, which means that it will be at exactly 0 degree. So the next thing is this switch is open and S2 switch is closed here. So your stator winding B dash get energized here. So when it is getting energized here, which means that the position of the rotor will be changed here. So it will be rotating in such a way that it will be aligned in such a way your 2 and 4 of the rotor will get aligned with 3 and 6 of the stator winding here. So as it rotates here, you can just see the first rotor teeth will take a position of 30 degree. It will rotate with an angle of 30 degree here. And in case of your third position, your switch C is getting energized. That is winding C dash with the help of S3 switch is getting energized here. So when it get energized, automatically once again your 3 and 1 position will be aligned with your winding C and C dash here. So you can just see the rotor position, it is taking an angle of 60 degree. So once again when you give A winding is excited, one more 30 degree will be rotated. It will move to the 90 degree here. So this operation, so when you each, it keeps on rotating. So 90 degree, how come it is now 90 degree here is, the number of stator phase here is, we have 3 here and number of rotor phases 4. When you multiply with this formula, you will get it as 30 degree. You can just see your stator phase is 1, that is dash, C dash. We have 3 phases and rotor is 1, 2, 3, 4 phases here. When you multiply, you will get it as angle is 30 degree. So for each pulse, the rotor is rotated at an angle of 30 degree. So next is the same variable reluctance motor. Suppose if you are going to switch on the first A switch here, that is A winding here, the position will be at 0. When you are pressing A and B together, when you press it, your 30 degree divided by 2, 15 degree will be achieved here. That is what you can see. And next is B is kept in the on position, your C is going to be in off position, so that you can move for next 30 degree. Next, your B and C are energized, so it will move to 30 plus 15, 45 degree. So this operation, it's called as off step operation. So your 30 degrees divided by 2, so we'll get it as 15. So your step angle is 15 here. So when you give each pulse here, the rotor position will take an angle of 15 degree. So this is permanent magnet stepper motor. You can just see how many phases we have here. You can just check it. So A dash 1, B dash 2. So your stator phase is 2 and rotor is 1, 2. So your M is 2, N is also 2. Substitute it in the formula, you get it as 90. For each electrical pulse, the rotor will take an angle of 90 degree. That is the meaning of it. So first, when you excite A winding, it will be at 0. When you excite B winding, it is 90 degree. So once again, when you excite A winding, it is 180 degree and it moves on. So that is what the operation is given. So this is full step thing. Suppose if you like to go for off step here, first is A is energized. The next is A and B together is 45. Next B alone is 90 degree. Next, when you give B, it is 135 and goes on here. So that is one. And next is hybrid stepper motor. So in hybrid stepper motor, we are going to use the second formula of the step angle. So this formula, NR minus NS into 360 divided by NR into NS. NR is the number of rotor teeth. So we had 5 rotor teeth and number of phases of the stator teeth is 4. When you substitute, you will get it as 8. So here, when you give first, when A winding is A dash winding is excited, the rotor will be exactly at 0 degree. When you give B winding exciter, it will move to an angle of 18 degree and it goes on like this. So for each step signal, it will rotate at an angle of 18 degree. So that is about stepper motor, servo motor. Servo motor, whenever you require a precise speed or a precise position or acceleration or velocity, whatever it may be, in such case, servo motor is used. So radar tracking guidance system, process controller, computer machine tools, in those these are the applications. So coming to once again to introduction, once again, it is also, as I said earlier, it is used for precise control of angular position, velocity and acceleration position here. So it is going to have a feedback loop here. So your servo motor is a closed loop control system, which means that automatically the speed can be controlled by taking the feedback of. So this is a basic diagram here. Servo motor system. Check it here. So the output of the servo motor, the error signal is given here. So the applied signal, both are being checked and given to the error corrector, and based on it, the angle of rotation is given to the system. So the servo motor, we have AC and DC. So DC servo motor, it's similar to that of your DC motor, where you will have an armature and field winding. So the operation is going to be similar to that of DC servo. And AC servo motor, we have 2 winding here, fixed winding and control phase winding. So based on these 2 winding phase angle here, the rotor get moved here. So that's all about special machines. Thank you.